Alright, so in the last video I talked about a simple one equation, one unknown. In this one I'm going to do a situation where we could have up to four unknowns in a question, and that can build up pretty quickly in physics. So let's just say that there's an object here. It's on a rough floor, okay? And so we have an object, a 10 kilogram object. Is pulled with a force, but it doesn't move. Okay, and if I said, okay, so if the mu static friction of the floor was 0.5, and what is the max force applied? Applied before it moves. Okay, so basically I got to set up the free body diagram here, which is another lesson, but right now I'm dealing with unknowns, okay? So here's my object. So let's say that I have a force going this way, okay? I have a force applied, and I want to know what that is, okay? Object isn't moving, but what's the max force applied that I can put on this object right before it moves? So I know that there's going to be a frictional force equal and opposite to it going this way. I know that it's going to have some mg going down, or some force of gravity, let's just call it that, and then I'm going to have some normal force going up like this to match gravity, okay? So there's my free body diagram, 10 kilograms, right? Okay, so what do my equations look like? Well, I'm going to have Newton's first law. Sum of the forces in the x equals 0. Sum of the forces in the y equals 0. Okay, and these are my components. So if I look at the x components, whatever's on the left is balanced by whatever's on the right. So if I make this my positive direction like this, I can just say, okay, well, I can say f of a minus force of friction equals 0. So f of a equals force of friction. Okay, no problem. This one, same concept. I'm going to say force normal minus force of gravity equals 0. So I'm going to say force normal equals force of gravity. Okay, so what do we have here? Well, we have a system of equations. That's all that we have. So this is my first equation. This is my second equation. I just used Newton's second law to do this. But what's the problem here? Well, I know that these are all balanced out because I have an object here sitting on a rough surface. 10 kilograms is pulled with a force, but it doesn't move. Mu is 0.5. What is the maximum force applied before it moves? So I'm trying to apply a force here. The maximum the friction is going to oppose. Okay, so I got two equations here. How many unknowns do I have? Do I know force applied? Nope. Don't know that. Do I know force of friction? Nope. Don't know that. Do I know force normal? Nope. Don't know that. Do I know force of gravity? Nope. Don't know that. Got four unknowns there. Right away, four unknowns. What are you going to do with that? Well, let's take a look at some other equations that we could use. Okay, if I started on this side, the third equation here, I know that the force of friction is going to equal mu times the normal. Okay, so I can take that equation here and plug it into here. Okay, fourth equation that I need, I know that the force of gravity equals mass times gravity. Take that equation right here, plug it into here, and that's it. That's the equation. That's the problem. What did we do? How many unknowns do we have? 1, 2, 3, 4. Okay, and I just plugged them in. I got this. So I said, okay, I need four equations. What are my other two? 3 and 4. You're done. Plug them in, solve. So I want you to look at this through a different lens. Okay, the lens of, okay, what are my unknowns? I got 4 unknowns. I need 4 equations. Do it like that. I mean, back here we knew what the mu was. We knew the normal was unknown, but that was already in this equation. We knew the mass. We know g, right? But that's all we needed to look at. The 4 circles. Okay, find the 4 equations. You're done.